Hi ma'am, so this is how I solved the problem given on soil compaction and field density. So you have a problem with a given, I am tasked to plot the compaction curve, determine the maximum dry unit weight of compaction and the optimum moisture content, and then calculate the dry unit weight for degree of saturation at S equals to 80% and 90%. And given that we have specific gravity that is 2.72. So this is a table, the result of the test. So first, I did plot the compaction curve, even if this is not actually the first process in order to plot this curve. So these are the values. So from this plot, we can see that the maximum dry unit weight that is equals to 125 pound per cubic foot. This is the yellow line, horizontal line, that is the pointing on the dry unit weight, and the optimum moisture content that is equals to 12.5%, that is the vertical line, that is the optimum moisture content. So in order to plot that curve, I did actually first solve for the values for the dry unit weight, respectively, that we have values for moisture. So this is the table of result. So how did I solve for these values? Values for the moist unit weight and dry unit weight, since we have this given, the volume, the weight, and the moisture content. So I solved these values in the formula. The formula for solving or getting the values for the moist unit weight is y, or the unit weight with moist unit weight is equals to weight over volume. So we have the given for weight and the volume, so you just substitute this given and you obtain data. That's 100.8, 124.5, and so on and so forth. So that's the moist unit weight. While for the dry unit weight, we have dry unit weight is equals to the moist unit weight divided by 1 plus the moisture content divided by 100, and then again and again substituting the given values. So we have obtained these values. So these values for the dry unit weight and the value for with the moisture content are the one that we use in order to plot that curve. So this is the table of the result again. So these are the values obtained using those formula. So in task C, so I am tasked to calculate the dry unit weight for degree of saturation, so that we have S equals to 80 and 90%. That's the degree saturation given. We have given the specific gravity that is equals to 2.72. So to manipulate the problem, so I did again plot a table obtaining the dry unit weight. So I have plotted the given for the specific gravity with respect to the moisture content. So at S is equals to 80, obtaining those values, I use this formula, that is dry unit weight is equals to specific gravity times the unit weight of water, which is 62.4 in SI unit, divided by 1 over plus JS times W over S. So with that, at S is equals to 80%, the degree of saturation. So we have the formula, so just substitute again and again the values. So we have obtained these respective values that we are going to use lately for plotting the curve. I mean the graph for this task. So the task C. So dry unit weight for degree saturation such that S is equals to 90%. So again using the formula. So substituting the values, we have these values obtained. And so these are the values that you have obtained using that formula. So we have at degree of saturation 80%, 132 up to 108.024 coming from moisture content, 8.4 up to 16.8, and so with the degree of saturation 90%. So these are the values. So since we have the values obtained, so I'm now capable to plot the dry unit weight versus the moisture content for various degree of saturation. So this line connection, the connection of this one at the top, this is the dry unit weight. So this at specific degree of saturation at 90%, while this one at the bottom is 80%. So that's it, and thank you.